We will be solving systems of equations using the Ti-Nspire. This is for TEKS 2A.3B, solve systems of three variables by using technology with matrices. So problem number 1. So rules of matrices and rules of solving is that you need to put these in standard form. X, Y, Z equals a number. So go ahead and put all three of these equations in standard form. In order to do standard form, we must move this 3z to the other side. So this first equation becomes 2x plus y minus 3z equals to negative 8. The second equation, I have to move over this negative y. How do I get rid of a negative y? I have to add a 1y to both sides. So negative 4 plus 1y is negative 3y. And on the last equation, I'm going to go ahead and get rid of this negative x by adding 1x to both sides. So remember that, again, the rules of these systems is that they must be in standard form. Every variable needs a placeholder. And now we're going to work on our matrices. So using a calculator page in your Ti-Nspire, so I'm on a calculator here, we're going to do reduced row echelon form. Okay, so what does that mean? That means the calculator is going to solve this for us. So we're going to go to menu, matrix. We're going to do reduced row echelon form. And so it's going to put the rref into my calculator for me. And now I have to write my augmented matrix. So I'm going to go to menu, matrix. I'm going to create a matrix. And our matrices are going to be 3x4s because I have 3 variables and I have my constant at the end. So 3 is the number of equations and 4 is the number of columns I need. Now I'm going to take the equations that I rewrote in standard form and I'm going to put my coefficients in place. So there's my first equation. Now also make sure that when you are writing these negative signs, that you are using a negative sign on your calculator. So we have to push -3, -3, and you can hit tab to go on to the next box, 6, 9. The last one we have 1, 7, 2, 19. When we hit enter, we're going to see our identity matrix, which is this first 3x3, and we're looking for non-zero columns. So these ones going diagonal tell me that this problem has a unique solution. It has one solution. If you see 3 ones going diagonally, then this last column is your answers, okay? So this has a unique solution, which means it has one solution. And my solution is -4, 3, 1. Okay. You might also write it as x equals -4, y equals 3, and z equals 1. Okay, so that's problem number 1. Again, these first 3 columns show me the identity matrix, and if I have 3 ones going diagonal, then my last column is my solution. Next problem. Okay, so problem number 2. Go ahead and rewrite these 3 equations in standard form. Okay. In standard form, the first one is already written for us. I don't have to move anything over. My second equation, I have to get rid of this positive x here. And I need to get rid of this positive 1 here. So how do I move over and get rid of this positive x, I'm going to subtract 1x from this side. So negative 5 minus 1x becomes negative 6x. Nothing happened to my y's. Nothing happened to my z's. Now I need to get rid of this positive one here, so I'm going to subtract 1 from both sides. So 21 minus 1 is 20. On the last row, I need to move this 2y. I need to get rid of it from this side. How do I get rid of a positive 2y? Well, the inverse of adding 2y is subtracting 2y. So I'm going to subtract 2y from both sides. What is 2y minus 2y? I'm actually left with 0y. Now, do we have to put the 0y? Not in our actual equation, but we do need to know that there are 0y's for my matrix. So again, how do we get to my reduced row echelon form? Menu, matrix, reduced row echelon form. And that's going to give me my rref here for me to see. This means that the calculator is solving this matrix for me. So now I have to create a matrix. How do I create a matrix? A menu, matrix. I'm going to create matrix. It is a 3 by 4 matrix because I have 3 equations and I need 4 columns. 1, 2, 3, and my answer at the end. So now you're going to go and you're going to get your coefficients. So your first row, 3, 5. Make sure you use the negative sign, -2, 10. Again, if you use your tab button, it's going to go to the next row. -6, -10, 4, and 20. And the last one, 2. And this is why I put the 0y, because you have to have a place for it, and it has to go with the y's. 5 and 5. Now we hit enter. So let's look at our identity matrix. Remember, identity matrix is these first 3 rows. We have a row of zeros, okay? By having a row of zeros, that means that one of these rows, we have more rows of zeros than we have constants. This is not consistent, okay? So we call this inconsistent. It's inconsistent because I can't have a row of zeros here in my identity matrix. Therefore, if you see a row of zeros, okay, like 0 does not equal to 1, okay? If you see a row of zeros, it's inconsistent because there is no solution. There is no numbers that you can pick to plug into X, Y, and Z that will make all 3 of these true. Okay, so again, you look at your identity matrix, which is the first 3 columns. And if you don't see your 1, 1, 1, then it's a special case. And these 3 zeros tell me that it's inconsistent. The next question. Go ahead and write these in standard form. Okay, for this first problem here, we're going to have to move over the -7y, or get rid of the -7y by adding 7y to both sides. So 2x, I have -4 plus 7y, and -4 plus 7y gives me positive 3y plus 4z equals -2. My second equation, I actually don't see an x. I'm going to go ahead and write it with the 0 so that I don't forget to put a 0 in place of x. And my last one, I don't have an x either. Okay, so I'm going to write 0x plus 2y. I have -3z, but I need to get rid of this positive z here. How do I get rid of this positive z? I subtract z from both sides. So I'm left with -4z equals 13. Now I'm going to click on menu, matrix, reduced row echelon form. Okay, remember that I need to see this in here for the calculator to actually do something with my matrix. Okay, now menu, matrix, I'm going to create a matrix. It's going to be a 3 by 4. Now again, we fill in our augmented matrix with our coefficients. 2, 3, 4, -2, 0, -4, 5, and 10. And then my last one is 0, 2, -4, and 13. If I see my ones going diagonally in my identity matrix, then that means that this does have a unique solution. Okay? It has a unique solution, which means one solution. And the last column is going to be your solutions. So these numbers right here will be your solutions. Okay? So x equals -197/4. Y equals -35/2. And z equals -12. Okay? The last question. Again, we need to rewrite these in standard form. On this first problem, I see this positive 4y I need to get rid of it here. So I'm going to subtract 4y. So 5 minus 4 becomes 1y. So 3x plus 1y minus 4z equals to 10. Okay. On the second equation, I see a couple things going on here. I actually have to get rid of both of these. So how do I get rid of a -x? I add 1x to the other side. So what is 5x plus 1x? 6x. Nothing happened to my y's. Now this positive 8z, I'm going to subtract 8z from both sides because 8z minus 8z is 0. Okay? And my third row is actually already in standard form. So I don't need to do anything to it. I don't need to move anything over. And it is written in the correct order. Okay, so now we're going to create our augmented matrix. What needs to happen before my augmented matrix? I need to select menu, matrix, and I'm going to select reduced row echelon form. And if you make a mistake, all you do is erase it. Let's try it again. Menu, matrix, reduced row echelon form. Okay, but I don't have my matrix there. How do I select my matrix? Menu, matrix. I'm going to create a matrix. Create matrix. And again, this is a 3 by 4. Remember, 3 equations is my number of rows. My number of columns is x, y, z, and the number at the end. I'm going to go ahead and put my coefficients into my augmented matrix. Second row is 6x, 2y, -8z, and 20. And my last row is -9, -3, 12, and -30. My solutions. I can see that this does not have a unique solution. I only have one row of answers, so these might look different, but my identity matrix, which is these first 3 columns here, my rows of zeros tell me that this is consistent, which actually means that this system has infinite number of solutions. That means that anything I choose to make the first equation true is also going to make the second equation true and will also make the third equation true. So again, By using your Ti-Nspire, you can look at your identity matrix to decide if it has one solution, if it has no solution, or if it has an infinite number of solutions.